Hey, now we're going to talk about solutions, how they dissolve, and how to read a solubility curve. So the rate of dissolving with solutions can be affected by a few different things. And we're going to talk about what some of those things are. So think about what some things are that you could do to affect how quickly something dissolves, say in water. Is there a difference between dissolving a solid in a liquid and a difference between dissolving a gas in a liquid? So let's talk about some examples. So if we want to dissolve a solid, say we want to dissolve salt or sugar, or you have some sort of a powder you want to dissolve in a liquid like Kool-Aid, we do this, we can increase the rate by stirring it, because when you stir it, the particles collide more frequently with each other, causing them to break down. We could also decrease the particle size. Think about it. Little tiny sugar granules dissolve faster than sugar cubes. So decreasing the particle size increases the surface area around each little particle that gets to touch the liquid, so that the solute are exposed to the solvent more. Because if you have a big cube of sugar, only four sides, 1, 2, 3, 4, 5, 6 sides are exposed to the solvent. Whereas if you have tiny sugar particles, each little particle is exposed to the solvent. Also, increasing the temperature. We know that if you heat up the water or heat up the solvent, we can cause things to dissolve faster. So if you want sugar to dissolve in water, you want the water to be warmer. We can stir it, break it apart into tinier pieces, and increase the temperature all at the same time. Now, if we want to dissolve a gas in a liquid, it's going to be a little different. So think about this. Think about a 2-liter Coke whenever you want to talk about a gas in a liquid. So if we want the gas inside the liquid, that carbon dioxide inside of our 2-liter, to stay dissolved, stay fresh, we don't want to shake or stir it. We want to keep the pressure high by keeping the cap on, because remember, it goes flat if you release the carbon dioxide bubbles. And we want to keep it cool, not hot. So gases and liquids, think about what you want to do with a Coke to keep it in great condition. You want to not shake it, you want to keep it cold, and you want to keep the pressure high. So carbon dioxide needs to stay dissolved in order to keep it fresh. When does carbonated beverage taste better? When they're cold, when they've got the cap on and not taken off, and when they haven't been shaken or stirred. So now let's talk about solubility curves. Solubility curves are very simple to read. They're just a basic graph, but they show how solubility depends on temperature. So we just said heating things up can cause some things, like solids, to dissolve better, but in a case like a gas, like carbon dioxide in your drink, it will just cause it to dissolve worse. So we're going to look at these lines and how to read them. So we've got KBr, KNO3, NaClO3, and NaCl. All these are right here. Okay, as each solution is heated, more solute can be dissolved. So you can see as we go from 0 to 90, all of these lines go up. That means we are dissolving more solute as we heat the temperature up. So you'll notice this line is very close to flat. That means it's not as affected by temperature. So a solubility curve demonstrates the maximum grams of solute or stuff that can dissolve at a certain temperature. So if I want to know how much sodium chloride can dissolve at 70 degrees, I'm going to look at my sodium chloride line. I'm going to go over to 70 degrees and say how much can dissolve. Well, I come to my line, and I see that about 39 grams can dissolve. So let's look at this. How do you know all of it will dissolve? So each line on a solubility curve, on these solubility curves, are for specific substances. So you can use a solubility curve to figure out how much will dissolve at a given temperature on the graph. For example, if I had 80 grams of KBr, notice it's all in 100 grams of water, so don't ever worry if they say 100 grams of water, it always is, and heat it to 50 degrees, all of the solute would dissolve. How do we know that? So if I go to 80 grams, I'm looking at KBr, and I'm saying at 50 degrees. So I'm going to go 80 grams over to 50 degrees, and I see that it falls on my line. That means that everything would dissolve. So the first thing that you are going to do is you are going to find the line that we're talking about. So in this case, KBr. So I'm looking only at this purple KBr line. And then we're going to locate the temperature and or the grams mentioned. Here we mentioned the grams and the temperature. So 80 grams. Grams are on the left side because it's grams. And the temperature's on the bottom. And then we look for where the point is. The point here is on the line. We said 80 grams, 50 degrees, it falls on the line. If it is on the line, that means it is saturated, meaning we are dissolving all that we can. So at 50 degrees, 80 grams is all that can dissolve. If we want more grams, that's going to be too much. It can't dissolve that much. And think about what we talked about in our towel. If you've got too much water on the towel, it's just going to drip out to the bottom. It's going to be super saturated. So if we tell you something, a point with grams or temperature, and it happens to fall above the line you're looking at, it is super saturated. If it falls below the line, that means you could add more. It's unsaturated. So say we only were looking at 40 grams of KBR at 50 degrees. So if I went 40 over to 50 degrees, that's below the purple line. That means I could add more because KBR can hold 80 grams. Okay? So let's look at this one. If a data point is above the line, super saturated, that means we've got too much solute. So the difference of on the line and how much more we have is how much is going to fall out to the bottom. So let's say instead of, we got 80 grams of KBR at 10 degrees Celsius. So we go 80 grams, 10 degrees, and I draw my point, my data point. That's what DP stands for. My line for KBR is down here. My point is right here. That's too high. It's above my line. So since the curve tells me right here, we could about 60, and I've got 80. 60 and 80, there's a 20 gram difference here. So I'm 20 grams too much. So that means 20 grams is going to fall out in the bottom of my solution. So because the point's above, that means I'm super saturated. Now, let's say it's not above, but it's under. So let's say I'm going to add 40 grams of KBR at 10 degrees Celsius. So I'm still looking at KBR, the purple line, and my data point is right here. So my point right here is I'm at 40 grams at 10 degrees, and my line could be right here. So I could dissolve up to 60, and I've only got 40. That means I could add more to it because it's below the line. It's unsaturated. Think about an unsaturated towel. You can wipe up more water. So how much more could I add? Well, I'm at 40, and I could be at 60, so I could add 20 more grams. So another example is if I add 80 degrees, let's look at NaClO3. That's the blue line. I'm looking at the blue line. So if I had 80 grams at 40 degrees, so I'm going to go 80 grams, 40 degrees, and make my data point. Notice it's below the blue line. That means it's unsaturated. But how far is it below the blue line? We're on 80, and it could go up to about 100 or 110, maybe 115. Okay, if it was 115, we could take 115 minus the 80 we have and get 35 degrees. 35 grams. We could add 35 grams more solute to this solution. Okay, so let's talk about more soluble or less soluble. So more soluble means that more solute can dissolve. So at 50 degrees, we have about, let's see, 38 or 39 grams of sodium chloride that can dissolve, about 80 grams of KBR and KNO3, and then about 120 grams of NaClO at that temperature. So for each example at 50 degrees, sodium chlorate would dissolve the most because it's the highest. At 50 degrees, it dissolves the most. Sodium chloride dissolves the least. It will only dissolve 39 grams at that temperature. So most soluble at a given temperature would be the highest line at that temperature. Least soluble is the lowest line. And it always is going to say per 100 grams of water. If it says 200, that just means whatever your answer you found, you would multiply it by 2. So let's look at this right here. So which substance is the most soluble at 0 degrees? 0 degrees, most soluble would be my highest line, which is NaClO3. Least soluble at 60. I go to 60, the least soluble is the lowest line, and that's NaCl. If I add 160 grams of NaClO3, so I'm looking at the blue line, at 30 degrees. So I'm going to go over to 30 degrees. Here's my data point. Will it be saturated, unsaturated, or supersaturated? So I'm looking at the blue line. This point is above it, so it's supersaturated. How much KNO3, red line, how much KNO3 will dissolve in 100 grams of water? At 80 degrees. So I'm looking at 80 degrees, red line. There's where how much would dissolve at 80 degrees. It's my red line. So that'd be about 160. Okay, if I add 40 grams of KBR, we're going to be looking at the purple line now, KBR, at 50 degrees. So I'm going to go 40 grams, 50 degrees, there's my point. Will it be saturated, unsaturated, or supersaturated? So say we're looking at KBR, the purple line. This point is below the purple line, so it's unsaturated. This is how much more solute can be added. So I'm right here, I'm going to my purple line, I'm at 40, I can go up to 80, so that means I could add 40 more grams. Okay, and last thing, remember, our solids dissolve better if we heat them up. So everything that's going up with an increase in temperature means they are solids dissolved in liquids. So like NaCl, that's a solid, salt dissolved in water. But if you see one that goes downward, like NH3 or HCl, those are going to be our gases, because gases don't dissolve well. Remember, we talked about our Cokes. Our Cokes have gases, carbon dioxide dissolved in them. We want them to be cold. So if your line goes down, that means it's a gas dissolved in a liquid. If it goes up, that means it's a solid dissolved in a liquid. When you finish with all of these questions, I want you to submit your digital notebook.